again. Talking about speed. Average speed. Triathlete A and B are competing in a triathlon. The first two legs of the race are swimming and biking. We want to calculate. Use the data in the boxes below to calculate each triathlete's average speed during the swimming and biking legs of the race. Average speed. When a plane is at its cruising altitude, it can travel at a constant speed for many hours, but the speed of most moving objects is not constant. So in a race known as a triathlon, the competitors or triathletes first swim, then bike, and finally run. The speeds of the triathletes change throughout the race. They travel slowest when they swim, a little faster when they run, and the fastest when they bike. Although the triathletes do not travel at a constant speed, they do have an average speed throughout the race. So to calculate the average speed, you divide the total distance traveled by the total time. For example, suppose a triathlete swims a distance of 3 kilometers in 1 hour. Then the athlete bikes a distance of 50 kilometers in 3 hours. And then finally the triathlete runs a distance of 12 kilometers in 1 hour. The average speed of the triathlete is the total distance divided by the total time. So looking at the distances, you would take your 3, 50, and your 12 and add them together to get 65. Total time, 1 hour, 3 hours, 1 hour, for a total time of 131 is total time of 5 hours. So then, to get our average speed, we need to go and put 65 kilometers per our total time, which is 5 hours. And then this ends up being 13 kilometers per hour was the average speed. Let's highlight average speed. So up here, the average speed is divide the total distance by the total time. So this is our distance, and here is our time. And it's color-coded. The blue one goes to there, and the green one goes to here. And the average speed for the triathlete is 13 kilometers per hour. Go ahead and try it on your own by figuring out the swimming and average speed for A and B. And also the biking leg, the average speed for A and B. Go ahead and pause and calculate those out. Next part, instantaneous speed. Suppose a triathlete B passes triathlete A during the biking leg. At that moment, triathlete B has a greater instantaneous speed than triathlete A. An instantaneous speed is the speed at which an object is moving at a given instant in time. It is important not to confuse instantaneous speed with average speed. The athlete with the greatest average speed, not the greatest instantaneous speed, wins the race. Let's highlight instantaneous speed is the speed at which an object is moving at a given instant. So what happens in instantaneous speed? You might be measuring their speed at that instant or that little part of a distance, but that does not give you. So thinking of the rabbit and the turtle, or a rabbit and the hare, one can be fast, but if it stops and the other one catches up, The instantaneous speed can be quick for the rabbit, but if he doesn't stay at it and get an average speed greater, then he usually will lose. Let's apply it. The triathletes run in the third and final leg of the triathlon, and you need to calculate their leg run. Leg 3 is running. Here's their distance, so calculate total time as 1.2 and total triathlete B, total time is 1.0. Use the data from all 3 legs to solve for each triathlete's average speed. So remember, when we're doing average, here's our equation. Average speed is total distance divided by total time. And we'll write that in our book also, so we can remember. And then go ahead, pause, and calculate those answers. To conclude, assess your understanding. The blank instantaneous or average speed is the speed of an object at a given instant in time. The instantaneous or average speed is the speed of an object over a longer period of time. Concept B, apply concept. The speedometer in a car gives the car's blank speed. I get it. Now I know to calculate the speed of an object, I need to fill in your answer. I need extra help with, and feel free to mention that if you do. All right.